B are symmetric matrices, prove that AB minus BA is skew symmetric matrix. So if A and B are two given matrices and it is given that they are symmetric, what does it mean? That A dash, the transpose of A, can be replaced by A and the transpose of B is same as B. And we have to prove that AB minus BA is skew symmetric, means the transpose of AB minus BA should be negative time of this. So consider AB minus BA transpose. You know, the transpose of sum or difference of two matrices is the sum or difference of their separate transposes. So it may be written as AB transpose minus BA transpose. And now you know that AB transpose is the product of their transposes but in the reverse order. So here AB dash may be written as B dash A dash, and similarly BA dash will also change the order, will be minus A dash B dash. And now A and B here. Now A and B being symmetric matrices, B dash may be replaced by B and A dash by A. So you get BA and similarly minus AB. And if you look at it, this is not the given matrix. Given matrix is AB minus BA. So you take minus sign common to make it AB minus BA. So what have we proved finally? So finally we proved that AB minus BA transpose is negative times of itself. So we can immediately conclude that AB minus BA matrix is a skew symmetric matrix because it satisfies that A dash equal to negative A is the requirement for a matrix to be skew symmetric. Okay, that is the requirement here. Okay, so we have proved it. Now show that the matrix B dash AB is symmetric or skew symmetric according as A is symmetric or skew symmetric. So this question has got two parts. In the first part, let A is a symmetric matrix. That means whenever required, we can replace transpose of A by A dash equal to A, it is given. And now we have to prove that B dash AB is a symmetric matrix. That means if you could prove the transpose of this remains the same. So consider, for proving it, consider B dash AB dash transpose. And here you take, though there are three matrices B dash AB, but you consider it as product of two, that B dash into AB. And you know the transpose of the product is the product of their transposes but in the reverse order. So it will become AB dash into B dash dash. You already know that the transpose of a matrix will give you the original matrix. So that will be B. And here AB dash with the transpose of the product is the product of transposes but in the reverse order. So AB dash will make it B dash, A dash, and this B dash dash will be simply B. And now since it is given that A is a symmetric matrix, I have already mentioned, so A dash can be replaced by A. So you have B dash, A, B. And this B dash, A, B is your given, matrix. So what have you proved? That B dash, A, B dash, the transpose is equal to itself. So we can conclude that the matrix B dash A B is symmetric whenever A is symmetric matrix. So that is your first part. And now let me take the second part. In the second part, it is given that A is skew symmetric. That means A dash can be replaced by minus A, and we have to prove then this matrix B dash AB is also skew symmetric. And to prove it, if we could prove that the transpose of this is negative times this. So consider B dash AB transpose. And as I told you earlier also, take it as the product of B dash into AB. And the transpose will be, the product of their transposes but in the reverse order. That is AB dash into B dash dash. Now AB dash will be again B dash A dash. That is the product of their transposes but in the reverse order. And B dash dash will give you B. And now this, since as mentioned earlier, as this time A is a skew symmetric matrix, so A dash can be replaced by negative A. So you get B dash negative A times B, or negative may be taken out. So negative times B dash A B. So what does it prove finally? That the transpose of B dash A B is negative times of itself. So clearly the matrix B dash A B product is skew symmetric whenever A is skew symmetric matrix. Question 6. Find the values of x, y, z if matrix A, the given matrix A, satisfies the relation A dash into A equal to the identity matrix, of course, of third order. A is already given to you. Let us work out A dash. A dash means transpose of matrix A, which is obtained by interchanging the rows and columns. So A dash this time will be 0, take the elements of first row, 0, 2yz in the first column, second row, xy minus z in the second column, and x minus yz in the third column. And now what is given? Now it is given that A dash multiplied by matrix A is identity matrix. Substituting the values, what is A dash? A dash is 0, xx, 2y, y minus y, and z minus z, z, multiplied with A. What is the value of A? 0, 2y, z, x, y minus z, x minus y, z equal to I, which in the next step I'll replace by it. Now take the product. Both these matrices are of the order third order, square matrix of third order, 3 by 3. So the matrix multiplication is possible, and the resultant matrix will also be of the order 3 by 3. By now you know very well how to take the product. That is the elements of first row to be multiplied with the elements of second column respectively. That will make it A11. So multiplying you get 0 plus x square plus x square. Shall I directly write 2x square? Continue the same process, multiplying with the first row to the elements of second column. You get 0, xy and minus xy. Please check, you will get 0. Continue multiplying with the third row. You get 0 and minus xz plus xz, so that will be 0. And now repeat the process with the second elements of the second row. Multiplying to the first column, you get 0, and second row. Yes, you get 0 and y multiplied. Multiplying the elements of second row with first column, you get 0 and plus xy minus xy, so that will be 0. Now multiplying the elements of second row with the second column of the second matrix, you get 4y square plus y square plus y square again, so that way you get 6y square. Repeat the process with the third column you get 2xyz minus yz minus yz, so you get 0. And now repeat the process with the third row. So you get 0 and minus xz plus xz 0, 0, 0. Similarly, in the third row multiplied by second column also gives you 0. Now check what you get when you multiply this with the third column. You get z square plus z square plus z square, 3z square. In this product is equal to the unit matrix of third order, that is 1 0 0 0 1 0 0 0 1. And now to get the value of x, y, z, let us equate the respective elements. So you get 2x square equal to 1, and replacing a22, rest of them are zeros equal to 0. In replacing a22, you get 6y square equal to 1. Replacing a33, you get 3z square also equal to 1. So x square equal to half, or x is equal to plus minus 1 by root 2. Y square equal to 1 by 6. So y equal to plus minus 1 by root 6. And z square equal to 1 by 3, or z equal to plus minus 1 by root 3. So these are the values of x, y, z. Plus minus 1 by root 3, plus minus 1 by root 6, plus minus 1 by root 3. I'm sorry, x is plus minus 1 by root 2.